Okay, so good evening, everyone. I'm going to be talking today about implementing SRE and our journey in doing that. Specifically, some of the things that I wish I knew last year. So what is SRE? So Site Reliability Engineering, which I'm going to use, say SRE to save myself about 1,000 syllables, is something that was developed by Google in the early 2000s to improve their scalability and reliability as they grew into the behemoth they are today. And one way of looking at it is that it is operations when done with a software engineering mindset. So, for example, thinking about release cadence versus reliability, not that those two things are have a negative correlation, but definitely if you're changing one, you will want to think about the other one. My name's Lachlan Holmes, Chief Technology Officer at First History. I've been everything from software developer, team lead, manager, director, and now CTO. Over the 25 years, I've been working at over a dozen companies. 3 of those have been SaaS companies, and most of them actually been healthcare startups. So the context I'm going to take today is SRE at a SaaS startup. First History is a digital health SaaS startup. We provide a way for patients to provide their medical history on their smartphone in advance of the appointment. So once the patient gets a link, they click on the link and it goes through the questions that model what a nurse or doctor would ask them in the first 10 minutes of an appointment. And then the summary gets sent to the nurse or doctor for them to review and save time and spend more time having the important conversation. So the technology at First History, we're a SaaS startup, so we have all of our infrastructure in the cloud. We actually have it in 4 clouds, which for reasons I won't go into today. We bring up all that infrastructure using infrastructure as code, and we have extensive logging, and we also use a full set of automated front and back end tests. And when those tests pass, we deploy using our pipeline to all of our servers around the world. We think we're pretty hot shit. So we went into production and life was good. And then one of the customers said they were seeing some slowness. We looked at our database queries, we upgraded our database, and we asked them what sort of performance they were seeing. So that's kind of the end of the story. I'm going to stop there because you can see at this point we're in this terrible, terrible place of not knowing what performance our customers are seeing. And that led us on the journey to developing an SRE capability at our company. So talked a little bit at the start about what site reliability engineering is. A crucial tool for site reliability engineers is observability. So a definition of observability that works for our company is that it is a way to measure how your system is performing, what state it is in, and how it got there. Let me dive into some details about that. So how it is performing, that is the whether or not you're providing a service that is able to provide an excellent customer experience. What state it is in is whether or not you're able to tell whether or not your system is up and running or not. And so when we didn't know whether we know whether our servers are up and running, we've got a dashboard for that. But in order to actually think about the execution and the functionality of our product, we would have to actually manually go through our application by hand. Not a good place to be. Another example of knowing the state of your system here I've got on the left, I've got a screenshot of a billion-dollar company that is saying that all their systems on their status page of their website, everything's good. And then third-party website Down Detector is saying that they're actually getting a lot of complaints from customers. People are taking to Twitter and saying that they're having some challenges with their product. Obviously, terrible for the brand and the people's perception of the service quality. So if you're unable to say whether or not your system functionality is working, you're really using your users as your alerting system. Not a good place to be in. And then finally, how it got there. So this is thinking about when you fix a problem, or when you're trying to validate a fix for a problem, you want to be able to reproduce it. And so a user will often have their variation of how they got there. I'm not going to say that users lie, but what they might say might be called alternative facts. And so it's good to have a reliable source of truth for how to reproduce a system state. All right, so what did we do for observability? The first thing we did, because we didn't have good latency measurements, is we just put in an API call from a different server and measured the response time on that API calls. Very quick interim solution. The next thing we did, though, was we added a load balancer. And we didn't do that for load balancing because we only needed a single server. We did it for all of the other things you can use a load balancer for. So it can help you to measure latency. It can track your error rate, as well as provide SSL termination and blue-green deployments. And so let me take a quick tangent and talk a little bit about that. So a really good quote I got from a DevOps advisor of mine, Todd Palmer. He said that you should treat your servers like cattle, not pets. What does that mean? It means that basically you don't want to be tweaking your servers over the course of their lifetime. And so what we've got, I've got a graphic on the right here, and it has the load balancer as the purple. And what we were doing, as I said, we'll bring up an infrastructure, and then we'd put our deployment on top of that. And then we'd just redeploy the next release on top of the same infrastructure. And what a blue-green deployment allows you to do is you bring up the infrastructure and you deploy on that. Let's call that the blue server. And then when you've got another release, you bring up identical infrastructure and deploy on that one. And you can test it, make sure it's working. When you think it's okay, use the load balancer to switch over from pointing to blue to pointing to green. And that means you've got zero downtime deployments. And it also means that if you see any problems right after you go into production, then you can very quickly switch back to the previous system. So we really benefited from that. So that was a good thing for us to be able to use the load balancer for, which we originally implemented for checking how fast our system was. Then we were looking at what state it was in. And for this, we added an application performance monitoring tool. A lot of different tools out there. We happen to use New Relic, but there's also Stackify, Datadog. There's open source solutions like Grafana and Prometheus. There's paid options that use OTel like Honeycomb. Like I said, there's tons out there. Really good for being able to not only see the latency, but also the state of your system, and also provide alerts. Then the next thing we did was we looked at our logging. We had logging, as I said, but we had logging in a variety of different places. And so we implemented a log aggregation tool. This is another thing where the APM tools often overlap with this. And so you can use New Relic or Datadog, Rollbar, Grafana and Prometheus and Honeycomb, they all do log aggregation as well. The thing with logging is that it's a bit of an incremental process. So you don't want to add a million logs and just log everything, because then you're going to have a whole lot of noise in your system when you're trying to debug, and that's not going to be necessarily helpful. Also, with these tools that I'm talking about, they're actually most of the time going to charge you based on the amount of logging that you do. And so if you've just got a ton of unnecessary logging, you're going to cost yourself more money than you need to. So the 3 pillars of observability are logging. That was the first one I talked about, as well as metrics and traces. So metrics, when we were looking at this, we decided to implement what's called the RED method, or RED metrics. And RED stands for rate, error, and duration. Rate is your queries per second, errors being like your 500 HTTP status codes, and then duration is the latency. So we were able to track those with our APM tool, and that put us in a much better position. And then traces, actually, sorry, I was just going to say the Google actually uses what they call golden signals, which are the same as the RED metrics, except they also include saturation. And that's a little bit of a more complicated thing that we, a bit more advanced. We didn't actually end up implementing that yet, and we'll see what we need as we go forward. And then, yeah, I won't actually go into traces in this today. Right. Okay, so I've talked a lot about observability today. Observability isn't the only thing in SRE. Another part of SRE is the organization culture change. So at our company, we had a team that was really good at taking features and implementing them, testing them, getting feedback. And so what we had to do as part of our culture was to add an operational element onto the end of that process. We have a small team that's able to really take charge of the entire process. And I think that's a really important thing to allow people to have the capability of fixing the things that they experience the challenge of. And so, for example, we don't have testers. We have developers writing automated tests. So when the product doesn't work through testing, it's the developer who wrote the tests that is then quickly able to actually implement that. So along those lines, we didn't want to bring in an SRE specialist and just make SRE their problem. We instead, because what that ends up doing is it sort of like ends up in a culture where you're throwing things over the fence. And so instead we're embodying this in our culture. Another important aspect that we wanted to do was empower developers. And so all of us in the team are able to, like I said, fix the things that we see the challenges with. And I've talked a lot about different technologies and tools today. And so you need to get the training and education to be able to use those tools. Often one of the developers will be primarily responsible for implementing that tool. And so they're going to do a talk, lunch and learn, in order to get that information across the team. Another thing that we found was useful is actually doing exercises to get people trying out the tools in a low pressure, non-production situation. And that was actually a lot of fun. We'd have someone go in and make a change, and then other people would try to go in and see, using the tools, what the problem was. The next thing is empathy. And so for a developer, not only do we get to uh, fix interesting problems, but another good part of the experience as a developer is we're able to provide solutions to users by empathizing with the challenges they have with what they're trying to use our product for. And so with SRE, who's the end user of SRE? It's us, the developers. So it's just a good thing to think about when you're trying to diagnose issues. You're thinking about what sort of information am I going to need to be able to diagnose that issue, and so the team empathizing with the team themselves to understand that information and be able to provide for the future them, right? So yeah, you want to be able to provide the information you're going to have when you're, say, up at 3 a.m. trying to solve a call. And speaking of calls, we've got after-hours support. We're primarily in North America at the moment for the development team, and so we don't have multiple people working in different time zones. That means that we have to have an on-call after-hours support. This is not something that we'd expect really to be used very often because after hours, things are less likely to go wrong. But when it does happen, it's really important for someone to be able to pick up the phone and be able to take down the information that they might be able to get from the customer. They might be able to start troubleshooting, make a quick turnaround perhaps, or at least just to provide a voice for the customer that they can talk about the technical details to, and that's really important from a business relationship perspective. So again, it's not supposed to happen very often, but when it does, it's really good to do a retrospective every time. And what you want to do is look into the reasons for that call. It might be that it was not an appropriate escalation to the development team, and so that would be communication with the other parts of the company to help them understand when to call the developers. Or it could be that a valid concern and you've got a bug and you want to make sure that bug, or actually that class of bugs, just really never happens again through a thorough retrospective. So next we've got process change. And so I talked about how to be prepared for having challenges outside hours. Ideally, you also just don't want the problems to happen outside hours ever. And big part of the cause for outside hours outages is releases. Any sort of change you're having happens to your system. So we have a guideline of only doing a release Monday to Thursday, so that if something does go wrong, we've got most of the team there able to help out and provide troubleshooting support. The next one was customer acceptance testing. So what we're doing is that when we have of course, when we have a breaking change, we want to let the customer know, but also when we have a high risk change, we provide a system to the customer that allows them to test their integration against the new changes, our new system, and we give them sufficient amount of time to do that testing so that when it goes into production, everything's all good. We also had to develop a rollback plan because a fundamental part of SRE is not needing the customers to get involved with the operation of your system. And so when you're running a system, ideally you'll have service level objectives, and you know that after you do deployment, if your system drops below a certain threshold on those service level objectives, you know that the process says that you should do a rollback. And in fact, if you have appropriate tooling in place and you're tracking those metrics, you can actually have the system just automatically do that rollback for you. And then we've got incident response exercises. This is a bit like the exercise I was talking about before, in which people get to learn the system. So an incident response is just practicing that very infrequent outage issue, just to make sure that everyone's comfortable with what they need to do, how they can handle an escalation. So triage and determining severity, and then they can sort of figure out whether or not they should start troubleshooting or bring in other team members to help out. The Simian Army from Netflix is as an example of this, in which they automated it. And this is sort of a branch of chaos engineering. It can be a good, fun thing to do, and it just decreases the amount of stress that people have when they're on call. Okay, so just to wrap up, in case you have forgotten completely everything I've said today, 3 key takeaways for you are to start thinking about SRE early in your development process. The bare minimum observability things to add to your system would be log aggregation and your RED metrics, the rate, error, and duration metrics. And then try to empower your team through training and simulations. Thanks very much. Feel free to contact me via email or LinkedIn, and I'll be happy to take any questions now too.